Good morning student. Today we are going to discuss the topic encoder. So encoder is nothing but a process of converting a data in one form to another form. So here I am going to convert the number in any form, either it may be octal, decimal, hexadecimal, to a binary encoder, because my computer are in general the computer can understand only the binary numbers. Okay, so that's why I am using encoders to convert a number in one form to a binary. That's my purpose. Okay, so here I am giving you an example encoder for converting a number in octal to binary. So we know the fact octal is, this number system is using 8 unique digits, 8 unique digits, and that's why in my encoder diagram I need the 8 input lines. I need 8 input lines, 0 to 7. And for representing an octal number in binary form, I need 3 digits. That is 2 to the power 3 is equal to 8 combinations. 2 to the power 3 is equal to 8 combinations. So that as octal number is having 8 input lines, I need 3 bits to represent in binary form. Okay, now you got the point. See, look at this second diagram. So R is nothing but the radix or base. So base of octal number system is 8, which means that 8 unique digits. Take this example. For example, 761 to the base 8 is an octal number. If you want to convert it to binary, how will you convert? So we'll use simple encoding procedure. See, by using this input table, what is the value in 7? Value of 7, 111. Value of 6 is 110. Value of 1 is 001. That's all. So the same I want to implement using this encoder diagram. So I have one logic circuit in between, input 8 input lines with 3 output lines. Okay, so if you give 7, if you activate 7, if you give the input as 7, it will give you 111. If you activate 3, it will give you 011. Okay, so this is what the input and output requirements. Now the question is, so what is the logic circuit? How we are going to get or implement P0, B1 and B2? So we have to write equation. We have to write equation for implementing the same. So how will you write equation for this? So look at the column, B2 column. So look at the B2 column. So B2 column is having 4 zeros and 4 1, which means that if you want B2, if you want the equation, the output B2 should be 1. So overall should be in high end, overall should be activated as high. The input line 4, 5, 6, 7 should be activated high. If you want B1 to produce 1, the input lines 2, 3, 6, 7 should be activated. And if you want P0 to be 1, 1, 3, 5, 7 should be activated high. That's all. So by using this, you can write simple expression. Now I am having expression in my hand. So for this expression, I have to draw the logic circuit. So this, my expression is having only addition operation. So to perform addition, I need OR gate. That's all. See here. So as I need 3 output lines, P0, P1, P2. So I used 3 OR gates, and overall the input lines to be activated is can be taken from the expression shown here. So see here. So these are all the input lines 0, 1, 2, 3, 4, 5, 6, 7. And for B2 you have to activate 4, 5, 6, 7. For B1 you have to activate 2, 3, 6, 7. And for B0 you have to activate 1, 3, 5, 7. So now all these lines were activated. For make you to understand, I'll give you simple example. For example, I want binary equivalent of 7. So look at this gate symbol. So 7 is activated in B2, B1 and B0, which means that all these 3 will give you now 1, so that you will get 7. And now look at 6, 66110. So it is activated in B2 and B1. So automatically the B0 value will be 0. Okay, so now hope you understand how the encoder is designed, how the encoder is designed with the help of input lines and output lines with the necessary equations, how to write equations and how to draw the logical circuit for implementing octal to binary encoder. So in the same way you have to do it for hexa to binary and decimal to binary. So only the input lines and output lines will be varied, and you have to look back the expressions. Once the expression is ready, you have to draw the logic circuits with necessary OR and AND gates. Sometimes if needed NOT gate, we can also use NOT gates. That's all. Thank you. Next session we will discuss decoder.